Dear participants, and a part of our machine learning and deep learning for engineers add-on course, we got this webinar. This webinar will be on artificial intelligence and machine learning for public safety, presented by Sohan from Type Communication, Sydney, Australia. Without He's a wonderful person, nice person, so you can always interact with them. Even don't worry about this is very short period, but anytime you want to interact with them, I'm ready to help you and I'll bridge you. You can always interact. He's ready to help us in all the way. So without much, he's such a wonderful person and he has got a very helping hand. So don't worry, we will extract as much as from him later sometime also. Not a problem. But listen keenly. Now itself, if you the first sight when you ask some questions, if you impress him, he'll be ready to help any extent. Okay. Without much delay, I hand over the session to Sohan. Please take care. The session is yours. Sohan, over to you.
Thank you, Sukumar, and thank you for those lovely, kind words. Sukumar and me have a very long history. We were classmates for 4 years in Karanya, and it was fantastic being his classmate. In fact, I learned quite a bit. He was a very studious student, and I see that he's still quite a studious man with a doctorate degree. So congratulations on that, Sukumar. Like what Sukumar mentioned, is today's session is going to be on artificial intelligence and machine learning for public safety. My background has been in public safety. And for those of you who do not know what public safety is all about, it is providing secure comms, secure data solutions, secure solutions to protect the community, the city, and the country. So it could be your police, law enforcement, fire, ambulance. Your Department of Defense is not basically public safety, but they do use technologies that are part of public safety. So I'll try to skim through the presentation as quick as I can. I have a couple of slides. So I'll try to go on the 4th to 5th gear. But if you do have any questions, feel free to ask anytime. I'm trying to take more of an industry approach because that's my background, being in the industry for the past 15 to almost 16 years. I'm going to show you the benefits of applying artificial intelligence and machine learning in public safety and how it reduces the workload on the current operational procedures that is undergone in field as well as in the control center. So without further ado, I'm going to go to the next slide. So this is the agenda: disruptions in the industries today on a very high level of what are the different technologies that are disrupting the various different industries or various different verticals, our lives today in this world. So I'll talk about that a little bit. I'll go into edge computing because in public safety, especially in ambulance as well as fire and police, there's a great need of using edge computing inside the vehicles, inside police cars, inside fire trucks, inside ambulance, and how does that benefit and the edge computing solutions that they're introducing today in these different verticals. UCC is something called Unified Critical Communications. That is actually bringing all the solutions together in one small little system. And then I'll segue into artificial intelligence and machine learning by introducing big data. As you very well know, that AI/ML relies a lot on big data. So I'll segue through AI/ML by touching into big data, then some of the AI/ML things that we are doing for public safety, and 5G networks, which is very well spoken about today, its benefits in industries like public safety, and a quick recap. So, you know, there are plenty of disruptions in various different industries, and we know that intelligent home is one of them. And this is more of a consumer mainstream. We see that with, you know, Alexa, Google Home, where you could have conversations with these devices, and your voice is converted into a text search, and it does a quick search and provides you an answer. It also takes instructions to turn off your light, to switch off or switch on your light. In fact, I have a Google Home at home, and I have 2 rooms that I have a conversation with Google to turn on the lights or turn it off. And whenever I travel with my family somewhere abroad, if I forget to turn on a light in my front yard, I just use my Google Home on my phone and say, please turn on front yard light, and turn it off at 6 in the morning, so that when I get up, I don't forget to turn off the light. So you see, things are getting more intelligent at home. We see things on edge computing with wireless driverless cars that have a lot of artificial intelligence, in fact, deep learning algorithms that they use to drive and avoid accidents and collisions. Healthcare services, which is part of my business, PublicSafety, are trying to embrace IoT, Internet of Things, to send biovital information of patients using 4G networks, and 5G would open up more opportunities for them to stream live patient data to a hospital before the patient is sent to the hospital. Then we have personalized deliveries. Uber Eats, Domino Pizza is already getting into all that stuff to actually deliver pizzas at your doorsteps. And then we're looking at smart cities and smart buildings, where we are trying to automate things, smart garbage collection, smart, water management, electricity management, to reduce costs and to provide a better, work environment for the people or for the residents living in these buildings. So these are some of the things that are disrupting the various different industries around the world. A bit on edge computing. So what basically is edge computing? If you go to the Gartner website and you go into their edge computing definition, they say it's part of a distributed computing platform in which information processing is done at the edge, closer to the people that consume this information. So basically, you're trying to bring computational power and data storage power closer to the edge, rather than relying on a central location that could be thousands of miles away. And that's what's happening today. You have data in cloud, and if you want to do processing, you send information from your edge to the cloud, data is processed, and it sends back to you, and you receive that information on the edge. But the disadvantage of this is you have latency. When it comes to public safety, every second counts. So you think about it, someone's landing up with a heart attack. You don't have time to process information in cloud, wait for the information to come back, get to know the historical medical information of this person, and then do the necessary medical procedure. You want everything instantaneously, because now life matters. In fact, edge computing is also quite useful for firefighters who get inside the building to put out fire. They can't wait for information to be processed in cloud and wait for it to come back. By then, the whole house is going to catch fire. So edge computing is processing information and storing that information at the edge. So how does it work basically? Rather than streaming information such as your video footage or your IoT data from your IoT sensors back to the cloud and processed and back to the edge, you do processing inside the edge computer, which means that edge computer is a processing device that has its own operating system, its own algorithms, its own intelligence to provide you that information instantaneously on the feed. So why does it matter? It does matter because if you have worked with Amazon, which I'm sure many of you have done, they charge you for the data that you send out. Sometimes I believe they also charge you for the data that comes in. They charge you for an EC2 instance. They charge you for data storage. And now when you're trying to scale this up to millions of users, even though you have a centralized mechanism of actually centralizing and doing things in Amazon, but now you're starting to pay not $100, but it scales to $4,000, $5,000, $6,000. I know about that because we deploy solutions today for small counties in the US, as well as here in Australia on Amazon. And we're also doing our R&D on Amazon. And we are developing a technology where we have used Kubernetes on Amazon to build a push-to-talk solution, which is very voice-centric. And we spend around, and it's not even in operations, but just for development, where we have built multiple instances where software developers can go and start working on code, distributing code, exchanging code, compiling code, testing code, getting code ready for production. And what about 5G? 5G is nothing else but going to be a catalyst for edge computing, because 5G is going to provide you low latency and a high bandwidth network. So today, traditionally, if you go and have a conversation with the ambulance, IT department, the fire, the police, you will notice that they have technology from various different vendors. They have someone providing them a modem for 4G, which is LTE, long-term evolution. They have someone providing the computing power, processing unit. They have someone else providing them a Wi-Fi hotspot. Then they approach companies like Carbon who provide them satellite comms. But, and then it results in this mishy-mashy system implementation, as you see in this picture. Bad cabling, they do not integrate to each other, each of these products. There's multiple communication networks with no convergence, which is no interoperability. There's no data integration at all in the field. So it's basically a big puzzle, which needs to be fit together, and it's also hazardous for health and safety reasons. So they're looking for something more simpler, where you can converge all of this, your compute, your storage, your apps, your location information of that particular device which is installed in the vehicle, the power, the satellite comms, the Bluetooth, LTE, Wi-Fi hotspot, LMR. LMR stands for Land Mobile Radio. I have a slide on it later on, and I'll tell you what are the advantages and what are they used for today. So they want to converge all of this together and bring it into one simple unit. And this unit will have legacy capabilities, which is working on traditional digital conventional radio. For those of you who are electronics communications engineers, I think you remember studying about LMR, conventional analog radio systems 15 to 16 years ago. That was what I used to study then, but it's still being used today quite heavily, because it is one technology that is quite robust and has been used, and it's proven its resiliency during critical times. You see these riots today in the US, where there's looting, and the police officers are not using LTE yet for voice. They're using P25 radio. And if that P25 radio were failed, then you will not be able to have voice comms with the police officers in the street, which means a police officer inside a violent mob can be beaten up, which is basically happening today in the US. If you walk alone as a police officer where there's a lot of riots, you're going to be beaten up. And back to the slide. So basically, this is what they're looking to have, a converged solution, and have things possibly in cloud or have that processed at the edge. So you see this on top, which was really a jumbled, ugly looking system from various different vendors, now becomes one integrated, intelligent device that can do computing in-house, locally, or can send that through an LTE network that can process it in cloud and send the response back, with the ability to also do legacy communication. So with unified comms, basically the first responders avoid the hassle of implementing unnecessary multiple systems. So I'm getting into big data and AI, but I just thought, let me get into this because this gives you an idea of how do the public safety work today before they start embracing things like artificial intelligence and machine learning at the edge. So the UCC platform that I just discussed is made of a data integration layer and a voice gateway. And then you have the edge platform. So the data integration layer is responsible for integrating networks to external systems via APIs, application programming interface, for location, status, and any other incident data. Voice gateways, voice interoperability between legacy systems and new networks. For example, if you want to have voice interoperability, analog or conventional, into a packet switched network, like on SIP, on TCP IP, you use a voice gateway for that. So this whole thing together, we term it as a unified critical communications platform. So this is a bit on the data integration layer. Like I just mentioned, you have your legacy systems over here. You also have your 5G, your Sigfox, your LoRa network, your LTE. These all can actually integrate to a data API platform where you can store data internally, and you can have third-party applications like your computer-aided dispatching, which police officers use today, which is software-based, to receive incidents from the field and also to send incidents to the police officer and that can plug into your API platform. And this data API layer can be a centralized platform to manage groups, single sign-on, IDMS for security, your identity management, basically. And this is basically what PublicSafety is doing today. They have they have a data integration layer provided by someone, a voice gateway provided by someone else, but we are bringing all of this together and supplying that to our customers. And that said, this is how a middle layer would work. You have your mobile distributed end devices down below. Then you have your sensors, and these sensors could be your video sensors, your GPS sensors, and then you have your bearer networks. Your bearer network could be your LMR, LT, Wi-Fi, satellite, Bluetooth, and at the edge you have processor, RAM. So this could be your edge computing device with bearer capabilities. And on top you have your cloud edge and your cloud integration layer to integrate to third-party applications, which is sitting on top. Could be your enterprise applications, your IoT applications, your dashboards, critical communications to have voice comms with the police officers, ambulance, and the first responders in the field. So where the solution, So where the data API fits in is in the cloud integration layer. And the voice gateway to integrate between your different voice platforms sits under the cloud edge layer. And then the whole thing is your UCC platform. So that's basically how it functions today, where you have an integration voice gateway for police officers, for ambulance, for fire to do their work. So the layman, the operational users really don't know what's happening behind, but from a technology platform, this gives you a holistic picture of how data is integrated between various networks, how data is received, and how voice is integrated, or there's interoperability of voice between different communication platforms. And obviously that is your edge platform down below. The whole thing, the UCC platform plus the edge platform, we term it has the middleware components. This is just a deployment of how you can deploy this solution on a mining truck. It can also be on a police truck. It could be on a fire truck. It could be on any various different vehicles that you have, utilities, water management, wastewater management. But in this example, I've taken a mining truck. What you see over here in the circle is your traditional LMR and your LTE hardware. And it has an LTE antenna. And you could also have a traditional radio installed over here, just in case your LTE fails or this device fails, you can use your handheld radio. Then you have an edge computing device that I spoke about, which will have MI, machine learning, artificial intelligence algorithms, whatever you need those algorithms to do in future. But for now, they usually do IoT, capturing of sensors from IoT devices, and stream this onto your LTE network, which goes through your CSP backhaul, your service provider backhaul, onto a control center where you can then manipulate the data, do anything else with the data that you need to, or also store the data on a RDBMS. So this edge computing platform could have multi-bearer capabilities. Like I said, you could create a Wi-Fi hotspot. So someone coming in with their UE, which is their end equipment, can tether to the Wi-Fi hotspot and start streaming information. Could be video, could be data. Or if you don't have LTE, you could then jump onto satellite and stream data onto satellite. Obviously, it's going to be quite expensive when you use satellite. And that's why people who are applying the solution, so-called edge computing inside the vehicle, are trying to use more of LTE and possibly 5G in future than satellite. They use satellite only in areas where you don't have LTE or Wi-Fi connection. They prefer using SATs. But the advantage of having a Wi-Fi hotspot is so that users can come around the vehicle and connect to the outside world using the vehicle as a hotspot. All right, so this is just an example of how we deploy edge computing with unified critical communications capabilities inside a mining truck. I'll just get into big data now. So what is big data? So if you look into the slide over here, I'm sorry, before I get into big data, do you have any questions so far? All right, silence is golden, so I'll assume no, but you can always keep your questions if you want to at the end, and you can ask me these questions. So what is big data? So big data is data whose scale, distribution, diversity, and/or timelines require the use of new technical architectures and analytics to enable insights that unlock new sources of business value, which is true. So, you have, it's going to be with more and more data that you provide. You have new technical architectures. You can use that for analytics, and this is going to create new business values for organizations like public safety, finance, medical industries, mining, etc. But there are three big attributes of big data, and we know that is variety, volume, and velocity. So volume is basically the huge volume of data. So rather than speaking about millions of rows now in your database, big data is talking about billions of rows and millions of columns. The complexity of the data and data type is referred to as variety. So now you're just referring to the different data sources, the formats, the types of data, which is structured, semi-structured, unstructured. I have a slide on that in the next slide. And then is velocity. So that's the speed at which the data is created. Rapid data ingestion into real-time analysis. Real-time analysis is very important for ambulance. You are in a vehicle, in a heart attack. You have the medical people out there inside the vehicle giving you CPR. So that person, they need to send real-time information to a hospital so that the hospital staff, the doctors in the hospital, can provide medical advice to the paramedics, and in fact have all the information ready before the patient with the heart attack is being dropped into the hospital. So what is driving big data today? So these are some of the things that I see is driving the big data. Is your mobile sensors. Plenty of mobile sensors out there. Social media. I'm a heavy social media website user. If Sugumar is on my Facebook, you will know that I keep posting a lot of different stuff on social media. But just like me, there are millions and billions of users using social media. And every second you have, thousands of status updates. You have video surveillance cameras. Police officers are very keen on video surveillance cameras. And I'll tell you how artificial intelligence and machine learning is going to be used in video surveillance. Traditional video surveillance was simple. Have a camera sitting down somewhere. Have someone in the control center monitoring the camera for 8 hours. Have another person come for another 8-hour shift. And then have another person come for the rest of the, hours, spending hours. And that's how you do video surveillance. But that's moving now. You have so much of data, historical data. How could you use that? How could you then apply AI, ML on top of it to start doing, providing security and safety for your citizens? Smart grids, medical imaging, gene sequencing. So these are some of the things that are driving this big data. That said, there are different data structures within big data. And, they come in multiple forms, including structured, non-structured, and financial data, text files, multimedia files, genetic mappings. For public safety, it is incident data. Incident data refers to the type of incident, which could be the type of crime, robbery, rape, bank robbery, fight, incident location, where the incident took place, the time of the incident, how many people were injured, and you say over here it shows 4 types of data structures, and 80 to 90% of future data growth is going to come from your non-structured data types. So if you start with, as you go up, there's more structure. When you come down, it's unstructured, but the future is unstructured data, video, voice, text. Structured data basically contains defined data types. And the structure like transaction data, OLAP, which is your online analytic processing. So these fit very well into your traditional DBMS. There can also be CSV files or your spreadsheets, your Microsoft Excel, stores structured data very well. Semi-structured data, on the other hand, are textual data files, and they're mostly, I would say, let's say, XML is an example. Extensible markup language, XML, is a good example of a semi-structured data file. Quasi-structured data, so that is structured, semi-structured, and then you have quasi-structured data. This is textual data with a bit of erratic data format. And it can be formatted with the effort and the tools that you have on the internet. For example, a web search, for me, kind of is like and the results are quasi-structured data. And unstructured data, no-brainer, is your video, text, PDF, images are unstructured data. And all of this data structure, structured, semi-structured data, quasi-structured data, unstructured data play a very, very important role as you get into artificial intelligence and machine learning. And we've seen that in public safety itself, where we have historical incident data. What can we do with that historical incident data? How we can make the city of Chicago safe? How can we make the city of Sydney safe with that historical video data, incident data, accident data, hospital information data? And all of this come in various different formats: structured, unstructured, quasi-structured, and semi-structured. So what is AI/ML? So I don't know if any one of you has AI/ML has been there for quite some time. If you get a chance, you should read this paper written by Alan Turing. I think it was written somewhere in 1940s or somewhere in that. Computing machinery and intelligence. He basically questions and he says, can machines think? And he starts giving reasons why machines can start thinking. And this was 1940, and he starts talking about how machines can start thinking using software. So AI has been there quite a lot. It's just recently that we have seen the benefits of AI in various different industries. So what basically is AI? It's nothing else but building intelligence inside a machine that leads to a suboptimal or an optimal solution when you give it a problem. In other words, AI is simulation of our intelligence, human Sohan's intelligence or Sukumar's intelligence by computers. So it's simulating human intelligence by computers. So, we program the machines using algorithms, and these could be simple if-then statements. From there, we create rules. We create expert systems, knowledge graphs, or symbolic AI. But these are all very weak AIs. If you want stronger AIs and you want things to start learning by itself, then you start talking about machine learning, and it is a subset of AI. It's a field in AI. Machine learning is a field which is a subset of AI that gives computers the ability to learn without being explicitly programmed. AI, you explicitly had to program it, but now you're taking that explicitly programmed code of yours, and you're now telling, I'm going to start building algorithms where you now start to learn on your own like a child. And within artificial intelligence, you have various different types of, within machine learning, you have various different types of machine learning algorithms. I'll get into that later on. I think I have 3 more slides on what is supervised learning, unsupervised learning, and reinforcement learning. And then we have inside machine learning, which is deep learning. And deep learning takes it a step ahead, because machine learning has restrictions when you start pumping in data. The algorithm says, thank you for this data, but I can't do much about it. Even if you start pumping in a lot of data, there is a limit to what it can do. But deep learning is a subset of machine learning that works very well with unstructured data, and it works very well with more data. And it functions as, on artificial neural networks. And I have a slide on deep learning, which is coming over here. The next slide talks about the different algorithms: supervised learning, unsupervised learning, reinforcement learning, and deep learning. But for proper AI, if you want to apply proper AI in any of your industries, you need the data, you need the algorithm, and you need the computing power. Maybe for some machine learning algorithm like your linear regression one, you really don't need high computing power. But as you start getting into complicated algorithms and getting more into deep learning, then you need strong GPUs. And so the trinity of AI, I call it the data, algorithm, and computing power. Not only me, but data scientists are the ones saying the 3 forces that are driving AI ML are data algorithms, and computing power. So what is supervised learning? So, I spoke about machine learning. I said it is a subset of artificial intelligence. And within machine learning, you have these 3 different categories. We started with supervised learning. And what is it? It's basically task-driven. So you need to guide the machine to perform a certain task. And you do that by providing it a data set. So the data set acts as a teacher. And then you have the algorithm using that data set and training itself. And then it starts making predictions and decisions whenever new data comes in. For example, let's say you have an image of a dog or a cat. You feed that inside, and it already has trained data. And it takes that data and it starts comparing it to the existing data that it has, which is its data set. Like I said, it acts as a teacher. And just like a human child, which is shown a cat and told what it is, likewise, this algorithm will say, I know that I have this data set, which you have given me, and now you're ingesting information like images into me. I have compared that to the data set that I've had, and I've learned to identify that it is a cat. And where is this used today? In public safety, it's used for crime analytics. So how does it work? You have raw input data, you pump it inside an algorithm. The algorithm talks to a supervisor or a teacher with a trained data set, and then you process that information, for example, the image of a cat, and then you provide the output. So key points are, label data is used for training over here, and some of the popular algorithms, to be honest, I just know a bit on linear regression, but the rest of the ones I'm just starting to work on right now. But these are some of the popular algorithms that you can use for crime analytics, for sales analytics. These are your linear regression, logistic regression. In fact, Sugumar, if you want to have, I can start having another session where we can just talk about the various different AI, ML, deep learning algorithms and how they are used for image processing, speech recognition. This is something that I plan to give internally in my company, but I don't mind sharing this information with you guys as well later on. But it's used basically for predictive modeling, like I said, crime analytics. Sure. So you have the...
Sure.
Cool.
Sure. We'll do it. Yeah.
Fantastic. Now we'll go to unsupervised learning. So unsupervised learning is data-driven. So the model learns through observations and identifies data structure, but it still needs a model. But it doesn't need that data set like your supervised learning. So you equip it with a data set and it finally automatically identifies patterns and relationships and then starts clustering it together. And it's quite useful for banks where they can now start monitoring unusual transactions because they know their data structure very well. Yeah, and using that, they can apply unsupervised learning to see unusual transactions, whether someone's trying to, take more than $40,000 when the limit is $2,000. I mean, it's a stupid example, but you know where I'm getting to. So it works this way: raw input data. It doesn't have no training data set, but it does have a model. And then it uses its algorithm. It does process and provides you an output. So some of the popular algorithms are your, a priori algorithm, k-means clustering. And one of the use cases of using it is in banks for unusual transactions. So supervised learning works with, it's task-driven. It has a data set. Unsupervised learning is data-driven. It doesn't have a data set. But it just has that structure, and from there it starts learning. And then you have reinforcement learning. So what is reinforcement learning? Again, which is part of machine learning. It learns to react to an environment. So this algorithm basically reacts with the environment and tries to figure out the best outcome. It learns from its past experience and tries to capture the best possible knowledge to make better decisions in future. So it's a hit and trial method. So with every attempt, it learns, it fails. Every time it learns, it gets rewarded, and it fails, it gets penalized. So this model is very useful because this is what they're trying to do for chess, and self-driving cars. So they're going to use a bit of reinforcement learning with deep learning algorithms. So input raw data, you send the data, it reacts to its environment, takes a decision is bad, penalized, decision is good, it's rewarded, and this way it keeps learning. Just like your puppy. When you give the puppy, you tell the puppy, don't poop inside, but it still poops, and you don't award it anything when it starts to poop inside. But once it learns how to go out, studies an environment, and it knows it's inside the house, it doesn't need to do anything in the house because it learned that it needs to do its business outside in another environment. And every time it does that, you reward it with a treat. So, that's how reinforcement learning works. And then you get the output data. So key points over here. Will be used eventually for self-driving cars. And these are some of the algorithms like Q-learning, deep AN, which is deep adversarial networks. There are plenty of algorithms out there. I've been having a look, and there are so many algorithms for deep learning, reinforcement learning, some which are used, but there are some basic ones. Yeah, so this just gives you a difference between the three different machine learning algorithms that I spoke about: supervised, unsupervised, and reinforcement learning. But these are the list of common machine learning algorithms. We use a bit of linear regression for jumping for auto voice bearer switching, and I'll show you what that is, to switch between one bearer to another. But the rest of the ones I think possibly you can use for image processing. CNN as well is something I heard that you can use for image processing. So yeah, plenty of list of algorithms out there, and maybe next session we can start getting more detail on how these algorithms are applied for each and every use case: image processing, speech recognition, text to speech, etc. All right, so what is deep learning? Deep learning is a subset of machine learning, and it's an evolution from machine learning. In case of machine learning, the system does not work very, very well with huge volumes of data. But deep learning, it scales up the performance with more data. So in simple terms, deep learning is a subset of machine learning which performs well and excels well with more data. And how it uses this layered structure of algorithms called artificial neural networks, ANN. And the design of ANN is typical to our human biological neural network, our human brain. And so yeah, there is plenty of things happening in deep learning on medical purposes to find out if a person has cancer or any other disease, even if he doesn't have cancer or any other disease, based on his genome type and his history, his parents' history. You can start saying he will have cancer at what age, and start providing him, diagnosing that, and telling him this is what he needs to do if he wants to prevent cancer. So, proactive rather than reactive. And as you see over here, deep learning algorithms will start to be used in self-driving cars, and also in manufacturing down below, for inspecting machinery to identify faults before they go into production, rather than putting them into production, then getting to know that 40,000 cars have an issue with their brakes, and then recalling all the cars. And Toyota has done that, Mitsubishi has done that. But with deep learning, now you can start inspecting machinery and immediately identifying faults which your other normal program language or a human couldn't identify. So you see there is a lot of benefits of these various different algorithms. Now that said, deep learning versus machine learning, deep learning does well with more amount of data, and that's why you see the performance gets bigger and better with more amount of data. On the other hand, with machine learning and other algorithms, it tends to hit a point where it does not do that very well. So I want to talk about auto network switching. Today, like I said, police officers use LMR for voice, LTE for data, Wi-Fi has a hotspot, and satellite in areas where there's no connection. So auto network switching is if you have this so-called edge computing platform that provides all the different networks, and you want the user to use a network that is very reliable. But to use the network that is reliable, you don't want the user to keep switching between networks. Now, as a police officer, I'm going out there to solve crime. I'm not interested to start looking at which network is available at any given time. As a paramedic, I'm there to save life. I'm not interested to see if satellite has better connection or to LTE or LMR. So I start thinking of now switching my network using algorithms. And so what happens in this particular example, you have LMR being used today, land mobile radio for voice. Obviously, the app sitting on the phone will not use LMR for voice, but it could use very little data like status. For status messages, it can use LMR, but for voice pictures, it'll start using LTE. Now, let's say your LMR fails. When it starts failing, you'll have an auto-bearer algorithm that kicks in. And then it looks at the available network. It says, oh, LTE is available. Let me switch to LTE. Now, as a user, I'm driving the car. I don't have any idea on what network I am. I just need to make sure that my bearers are available at any given time. So now I'm on LTE, and now I have voice comms to the control center. Now the LTE fails. So it looks if LMR is up and running. No, it's not there. LTE is not there. So it goes to satellite. And so this way it starts to learn. And then it'll get to know where are the different black spots for LTE? Where are the different black spots for LMR? And then using a combination of supervised, unsupervised, and reinforcement learning, it will start providing better, accurate switchover mechanism for the users in future. So this is something that we are working on today to apply AI/ML on auto vehicle switching, auto bearer switching, or auto network switching is the right word. So can AI solve crimes? So these are some of the use cases of AI for public safety. And the answer to this is yes, there's so much of increased lawlessness today in the world. So how do you prevent this lawlessness? How do you prevent a crime from happening? You have cameras today, you have police officers in certain areas, but they usually catch the person after the crime has been committed. So when a person is walking with a gun inside a school and trying to shoot the students in the school, how do you prevent that by happening? Can you use intelligence inside, embedded in computing platforms, in edge cameras, to alert you that there's someone walking and trying to kill someone in the school? The answer to that is yes, and that's where machine learning is going to provide you a solution. This is just an example to show you the difference between a human and a machine. Now, if I had to ask Sugumar, can you just count the number of cats on this picture?
I think three.
Say three.
Three pictures has got cat.
That's okay. Sugumar said three, and that was and he's taking his time. Well, he got a chance. He started with three. Anyone else want to say how many cats? So Sugumar, three cats. All right. So there are 8 cats, and there are 8 croissants, by the way.
Wow, great. Great.
And it's just a simple example to show you the following: image processing, image analysis leads to a simple conclusion. The visual error rate for human remains the same. And also it's a bit confusing. For the first time, I thought there was just 4. And then I said, no, 5. And then I had to pay a lot of attention. And finally, I figured out it's 8. Whereas algorithms will learn slowly, but will drastically decrease their error rate in future. And as you see, the humans can remain constant once they figure out that it is 8. But the algorithms, and as you keep pumping more cats and more croissants, you'll start making mistakes. But the algorithms will get better and better and better with more data. So the same principle can be applied to other fields like text analysis or speech recognition, for improving voice recognition for people with impaired speech, for example, or for someone with a foreign language detection. Someone come to the US speaking to a police officer who speaks only Mandarin and doesn't speak English. So now the police officer is trying to understand what that person is saying. So can we have algorithms embedded inside the police officer's devices to start to recognize that it's Mandarin and provide the officer, voice conversion to English and reply back to that person in Mandarin using the device. So these are some of the things that the police officers can use in the field. That said, the one other thing they're using is for facial recognition. And this is very crucial for police departments. They use facial recognition to identify criminals who are on the run or who are missing. So AI promises greater accuracy than humans in matching faces. Traditionally, you would have 3 or 4 people looking at the face and saying, I think it is this one, but I need more images to verify. But now with machines, if you have historical image data, you could do image processing, and this saves hours and hours of time to actually identify the missing person on a criminal. So this is one of the use cases for public safety, is facial recognition. The other one is video analytics. You see in this example out here, you have recognized that this car is wrongly parked. So I'm not a fan of this video analytics, because I have a tendency of parking and not taking my car, even though it says 1 hour. I park for 1 hour, 30 minutes and get parking tickets. So with this technology, I'm not a fan. But this can be used by law enforcement to fine ticket people on the spot. So if you have more than 5 minutes overdue of your parking, you don't need a parking ranger now to give you a ticket. You have intelligent cameras out there who say, okay, this guy has parked there for more than 1 hour. I'm going to fine him. If you're driving, you speed, you're speeding and you drive past pedestrians who are crossing the road, and you can capture that picture as well. If you're trying to park and you hit someone over here, I've had this happen to me multiple times, where someone tried to park their car and they've banged my car, and I go for my shopping and I go to my car and I see the bumper is destroyed. But if I had cameras around and they were using machine learning algorithms, when the accident took place, the police or someone could be alerted that there's an accident in the parking lot, and you can get the number plate of that person. You can track the person as well using video tracker. So this is some of the uses of machine learning in public safety. The other thing is predictive policing. Predictive policing works in such a way where I spoke about linear regression algorithms in supervised learning. We apply that for predictive policing, where we say that I have historical data for robbery, crime, burglary, criminal damage, theft, and now I want you, algorithm, supervised regression learning algorithm, to tell me when will be the next crime. And the system looks at historical data and says, okay, today 6 o'clock, there's possibly burglary in Smith Street or Stevenson Street, for example. So that is predictive policing. And this enables police officers to deploy people in areas because the system has predicted a crime. And so police officers can pay more attention to that particular area. For ambulance, it's quite useful, because using this predictive analytics, you could say, in a given area in Coimbatore, for example, there's been a lot of accidents. And so we need to have a hospital close by to that Coimbatore junction where there has been a lot of accidents. So that makes sense. So that is predictive, using predictive analytics with supervised learning algorithms. The next is robots. What you see on top is a robot from in New Zealand. So the New Zealand police have basically implemented an AI robot, and it's called Ella. And Ella is a lifelike virtual assistant that uses real-time animation to emulate face-to-face interaction with an empathic way. She can smile, she can go sad, she can be happy, she can grin. And this is just an example. People can go and interact with Ella. She's going to be stationed in the lobby in the Wellington headquarters. And visitors can go and have a communication with her and tell them where's the criminal department. And she will say good morning, she will smile, and she'll direct them to the criminal department and also give them a pass. So now you don't need someone to actually sit over there giving people a pass. So this is going to be automated using machine learning and robots. Then Dubai has implemented that on top, as you see. So they are experimenting with street robots that can transmit data back to the headquarters. So you can talk to a robot in a street and tell the robot, listen, I need this information. And this information will be provided by a robot on the touchscreen. And if it doesn't know, it fetches this information from an external system using a cloud platform and an LTE network, long-term evolution network. Now think about this. When you deploy 5 of these or millions of these robots in a city, the LTE network won't be able to provide you the required latency and the bandwidth. That's where 5G comes into play. The other thing is bomb squad. Bomb squads are using this to detonate bombs. Traditionally, you would use a small little device like this, and you'd have someone manually trying to detonate the bomb, but now you're making the robot think. The robot will say, okay, I think based on my image processing, object recognition, material recognition, that this particular device has a bomb inside. I've done whatever scanning that is required. So I am going to perform these activities. And do you, as a human, agree for me to perform these activities? All you have to say is yes or no, and then it does what it has to do. So now you're making the machine do object recognition, image recognition, come up with a conclusion, and say what needs to be done. So that's another application of artificial intelligence and machine learning in public safety. And then is drones. Drones are mostly used for rescue missions. If you have someone getting lost in a forest, you can't send officers to go and search for them. You only can send now drones with infrared, imaging cameras, and they can spot a missing person. And if they spot a missing person, they can send the location of that missing person back to a control center. They can also be used for monitoring power lines. Today, if there is something wrong with the power line or in a oil line, you have to send a person with a vehicle to monitor and check it. But these guys can actually fly over a power line and find out where there is an issue with the power line and send the location of that of the issue with the power line back to headquarters, and then you can deploy someone to go and fix it. What is the advantage? You're saving money because you're not unnecessarily deploying a person to go and fix a power line or a oil or gas line. So this is another use case, use of drones and edge analytics. So you can send a picture of a missing person, and as the drone keeps going on a crowd, flying over a crowd, or even video cameras that are looking at people in the city, it recognizes that John Smith is a missing person, and he was spotted on Cook Street at 6 in the morning, and he's heading towards the railway station. Or a person of interest, you can spot that person as well and trigger an alert inside the control center. Again, all of this, you don't need people sitting and looking at the video camera. You use machine learning algorithms with video analytic capabilities, image processing capabilities to provide you this information. And this is a great technology, mobile text recognition. This is nothing else but a simple app on your phone. You can use this app to read meters, or you can use this app to scan license and number plates. So it's AI-based mobile scanning app that can instantaneously read structured or unstructured data from license cards, utility meters. So what is the advantage? This technology basically eliminates the need for typing. So basically, you just point your phone that has this app, scan the data directly into your app, and bang, you have all the information about the car or about the meter or anything that you have scanned. So that is mobile text recognition. The other one is augmented reality. Very, very useful for police officers, for firefighters. Firefighters are looking for smart helmets. This smart helmet needs to have AR capabilities. So AR is basically, it's different from, basically, you take digital information and you overlay it on real world via a headset, glasses, or smartphone. And companies are starting to build smart augmented reality headsets where you can start detecting other firefighters and detecting walls using smart edge detection. You can also see where the hotspots are, so you can avoid the hotspots and not touch them as a firefighter. You can see the thermal edges of the building. You can also see information such as your biometrics, how much of oxygen you have, how much the oxygen your partner firefighter has. If you have cameras inside your augmented reality headset, you can stream this information back to a central command and control center. So I'll give you an example of how firefighters in a regular vision today get inside a building to put off fire, and how using artificial intelligence machine learning algorithm from a company called See-Through, you can now detect the other firefighters clearly and also detect the edges of the walls and hotspots. So this is just an example of the application of machine learning inside augmented reality headsets. On the left is regular vision, hard to notice what is happening. On the right is using machine learning inside augmented reality headsets. Now, there's a firefighter over there. He went inside the building. You see the hotspots on top. You see the contour lines of the wall. I mean, as a firefighter, which one you'd find easy? Obviously the right here rather than the left. The left, I've been told there are multiple firefighters who have reached the door with the victim, and both of them have fallen and died just because they were not able to see the exit, and they were just few meters away from the exit. And with this technology, you're going to be able to save a lot of lives and do your work more efficiently. The other example would be gun violence. So, if you had gun violence in the year 2018, there were around 323 mass shootings in the US. And this number is 346 in 2017 and 382 in 2016. But with AI, you can stop such type of shooting by preventing the threat, by using preventive threat detection and tracking of the person. So this is how it works. Over here, artificial intelligent cameras are used to analyze the data of their surroundings, stationary objects or moving objects. So now the AI algorithms will start analyzing the surrounding, and it starts detecting this person. And it uses object recognition algorithms to recognize that this person has a gun. It does that by either sending it in cloud, or it can do local processing as well. But now that it knows that there is this person entering the school with an AK-47, and it recognizes the object the person has, possibly even does a facial recognition and know that this guy has a lot of criminal history, he's been in violence before. The third step is it triggers an alarm and sends the information to endpoints. Could be a smartphone, or could be to a police officer, or could even trigger an alarm in the school, where everyone now gets to know there is something happening and they need to go and take cover. Otherwise, they don't want to be caught off guard when the person with the gun enters the school and starts shooting. And with this technology, you're alerted that there is something that's going to happen. And then with that alert, you can send a police officer with the location of that person, the type of gun he's using, possible even person identification if you did facial recognition, and catch the bad guy before he goes and does something. All right, the last one I want to talk about is deep fakes. There's significant concerns now about deep fakes, because now with AI, you can actually start manipulating what people are speaking, even though they're not speaking that thing. So you see this example on top, you see the cyclist cycling over here. That's a real picture of the cyclist. But down below, someone's has used algorithms to generate cars coming from here. And it is a video. It's not even a picture. It's an actual video. So they've generated cars coming from the other side. So, this person can basically say he fell off the car because he fell off the bike because of the oncoming cars. And he can manipulate this picture, and he can send it to the insurance and say, see, you see there were cars coming, and that's the reason I fell. So deep fake is basically using videos, pictures, and manipulating them and creating realistic voice and facial impressions of human beings. And this is an example of Obama having a talk. This was the reference, and someone else started to speak on behalf of Obama, superimposed that on his reference, and this was the final result. So it's now getting harder to spot a deep fake, and it's going to get harder and harder in future as the algorithms become smarter, less predictable, more intelligent. You'll have a lot of deep fakes. Tomorrow they may even have the president of the US. It may not really be him, but someone may fake him and say there's a national emergency. Everyone get into your house. It may not have been the president who spoke that. It may just have been a deep fake algorithm that created that thing. So you can hack the websites or hack the television sets and just throw this video on board. So deepfakes are becoming a concern also for public safety. Not as much yet, but in future, yes, because they are starting to embrace machine learning for object recognition, image processing, facial recognition, and they are worried that if the video if the video is given to a bad guy, or he gets hold of the bad guy, he can manipulate and tamper with evidence using algorithms. All right, the last one is social media integration. Do you all agree that before you call the police, you put things on social media? If something happens, you put things on social media. You know, public safety are coming to us and saying, before they call for rescue, before they call an ambulance, they have this on social media. So is there a way to capture social media information and create an incident out of that? And the answer is yes. So you have machine learning out there, algorithms that start to sniff social media data and say, okay, seems to be a real incident. Now I'm going to package this information, unstructured data, and send this data into readable format as an incident to public safety, who can then see this incident and say it's a social media created incident, seems to be authentic by the machine learning algorithm. I'm going to dispatch a police officer in this one's house. So you have algorithms that are starting to do that today, and we are also thinking of working onto that. So that's basically it. There was something on 5G that I wanted to talk about. What is 5G in few words? You know, it is a low latency, ultra reliable network with ultra fast connection in gigabits per second. So it's going to provide you low latency, URLLC, quite useful for augmented reality applications like I just spoke about, the firefighter using augmented reality lenses for, say, facial recognition. We spoke about that, how facial recognition can be used by police officers to catch the missing person or the person of interest or the bad guy. And then, you know, you have this massive machine type of communication, IoT sensors, for example, and I'm sorry, enhanced mobile broadband connection. EMBB is enhanced mobile broadband connection. So you're guaranteed huge amount of data rates, around 10 gigabits per second on demand at the edge as compared to what you get today. And then you have MTC, which is machine type comms for IoT, incident noise detection. For example, if someone shoots a gun, you could have sensors and that could recognize that it's a gunshot and alert public safety that it was a gunshot, for example. So IoT sensors, enhanced mobile broadbands, and low latency is what 5G promises. And it's called the magic triangle because of these three things: EMMB, MTC, and URLLC. And 5G is going to be a catalyst for edge computing. There's going to be a massive rollout of machine learning, deep learning algorithms at the edge once 5G comes into play. So there is a lot of benefits of 5G. Yes, people are talking about the ill effects of 5G, but I always tell them that 5G works on, we all are engineers, we know it works on ionizing frequency, non-ionizing frequency. You have non-ionizing and ionizing frequency. And 5G works on less than 30 gigahertz. Once it starts getting to 300 gigahertz, yes, we do have a problem. But now we do not. But long-term implementation will show us what are the health effects. But as of now, I see a lot of benefits of using 5G for massive broadband connection and ultra reliable, low latency use cases like augmented reality, facial recognition. Think about it. You have a doctor sitting in Sydney who wants to operate on someone in New York. And when he starts operating that person using, machinery where he's just sitting and, working on someone's body part, and there's another doctor physically located over there to see that everything is going all right, a couple of nurses, you want low latency network. You don't want him to press a button over here and he cuts a vein and he's supposed to stitch the vein immediately, but he's still waiting for a response. So, 5G solves that problem. Now, this is just an example from a medical point of view. And for public safety, what 5G is going to do on a public safety mobile broadband network is with 5G, you can start splitting the network. It's called network slicing. So you slice the network. You can't do that network slicing on a 4G network today. The reason you can do it on a 5G network because it's a huge bandwidth network. It does edge computing, edge processing as well. So in this case, you can say, I want a virtual network only for video cameras. I want a virtual network only to receive IoT sensor information from vehicle data. I need a virtual network only for voice comms. So these are the benefits that 5G can bring in for public safety. And this is just a slide that talks about emerging mission critical cloud computing. Today, everything is done on premise. All installations are done on premise, whether it be your video management, records management, and it's expensive to manage and maintain, and you need dedicated resources. But the future is trying to have it on cloud, create virtual infrastructures. It's already happening on Amazon, but also trying to deploy more of it at the edge rather than in cloud. So a combination of cloud and edge computing is the future for public safety computing services. And and the benefits are it's cost effective. You can have a subscription model. You can provide software as a service rather than providing it on premise and having it expensive as a software licensing model. With the SaaS, it's a bit more easy and cheaper because of you don't maintain it as a customer. You let the vendors maintain it, upgrade it, etc. All right. So quickly recap. We spoke about the legacy networks on a very high level that LMR is used today. We showed how we can bridge the gap between legacy networks, LTE networks using the so-called UCC concept that has a data API layer, a voice gateway layer. We spoke about AI, ML, artificial intelligence, machine learning, having the supervised, unsupervised, and reinforcement learning and deep learning, and how the supervised learning along with reinforcement learning algorithms can be used for switching voice between different networks. A few use cases on facial recognition, gunshot, object recognition, augmented reality is something that I spoke about, applying ML use cases in these particular environments. And finally, 5G, which is going to be a catalyst, not only for IoT, but also for ML applications at the edge in future. So that's about me. Thank you very much for your time. I hope I was clear and I was not very fast. But if you do have any questions, please let me know.
Dear learner, do you have any questions? You can unmute and ask him. And meanwhile, I just ask a few questions. If you're ready, I'll start my questions, right? So, yes. Sohan, I just want to know, like, what are the platform you do develop your program? In which platform you do develop your programs? Algorithms.
Algorithms usually Python. And we also use a bit of R to develop these. But when it comes to we also use Ruby on Rails, C for the actual application that interacts with the user. But the algorithms are Python. In fact, the auto bearer switchover that we built to switch between different networks was Python on Linux.
And then, and you talked about IoT, 5G, all this. Is it? See, almost you covered every future happening topics. I think I can. I want to tell you in the time of what of thanks. But which area you recommend students? Because it's not like every area is like you recommend them to step into AI or 5G or IoT. Is it like it depends on their interest, definitely, but as a communication engineer, as a mechanical engineer, like which area you prefer, like in general?
See, sure. Yeah. Traditionally, as a electronics and communications engineer, I know what we tend to do. We tend to get into more of voice comms, satellite communications, network stuff, but that's changing today. So it doesn't matter what field of engineering you are, but if you can do what you like, that is very important. Even in mechanical engineering, you can start applying artificial intelligence for manufacturing, for example. So if you are to ask me holistically, what is changing today in different verticals, be it public safety, be it medicine, be it mining, be it utilities, water and wastewater management, or be it in other segments within government, it is artificial intelligence, machine learning, and IoT with 5G. So if you want to get with edge computing, so if you want to see the future, look into getting 5G will come. It's going to be deployed in another 10 to 12 years. You'll have great 5G performance, but then what? Then you need to upgrade it maybe to a 6G network. So if you start with 5G, you will continue remaining in voice communications. But if you want to start getting into programming and start making machines intelligence and automating tasks, get into artificial intelligence and machine learning. In fact, in Google doesn't rely on Cisco. Google doesn't rely on Juniper for its networks. Google has its own software-defined networks. So now, they're building networks using software, using artificial intelligence and machine learning. So they're getting out from the traditional layer 2, layer 3 switching, which we communication engineers would go install on a rack, a layer 2, layer 3 switch, get into the prompt and start configuring VLANs and all that. That's all going away, and it's getting more into the software field. So if you had to ask me, get into things like IoT, 5G, if you still want to continue doing voice for the rest of your life, because remember, voice will never go down. There's always going to be voice, be it on 5G, 4G, or satellite. And if you want to get more into data, then you can think about doing more of machine learning, artificial intelligence, and IoT. Because remember, there are two streams, data and voice.
Oh, that's great. You've given even for me, some clarity was there about your, like, instead of stepping into multiple discipline, like once you become an expert, you can get into multiple discipline, right?
Correct.
Yeah.
And that said, things also have changed with voice, because now voice has become data. It was circuit switch networks before. Now we are talking about packet switch networks, and now we are talking about SIP Pro, SIP on TCP/IP, UDP. Now voice is on TCP. Yes. Before it was conventional analog voice. So I keep talking about voice and data differently, because my field, my domain is where they still use traditional voice for comms, and they will never get away with it till they see that packet switch networks can offer them resiliency, scalability, reliability, like circuits, like traditional voice networks that are offering today. So don't get into traditional voice. I think as a newbie, IoT, 5G, artificial intelligence, machine learning is something you should get into. Sorry, go on.
Yeah.
And why can't you do our machine learning in voice? You can also do machine learning in voice. I'm doing machine learning in voice. I'm building algorithms.
Hello, guys. Is there any questions? Are you all there? I think, hello. Hello, guys.
Don't feel shy, guys. Don't feel shy. Whatever questions you have to just ask.
Hello.
Nothing is a dumb question.
I'm audible, Sohan. Are you able to listen to me?
I think my
internet is not.
I can hear you. Can you hear me? Can you hear me? I can hear you, Sukumar. Can you hear me, guys? You went off the meeting. All right, so gentlemen, do you have any questions? If you have any questions, by the way, Sukumar is not around, so you can ask the questions if you want to.
Yeah, I'm back, Sohan.
I can hear you.
Yeah. My net was not that much stable. It is mobile net. That's the reason. If there is no questions, I think without wasting much time, we'll wind up the session, right? Guys, if you have any questions, you can write to him or you can ask me. I'll post him, okay? And then get you the answers, right? Sohan, very much thank you. It is very nice presentation, crystal clear presentation, and I never seen this type of industry people will try to stuff in many things, but the same thing had happened. But every slide has got a lot of information and very helpful and neat and clean, crystal clear information. You covered every technologies, starts from AI, ML, deep learning, IoT, 5G, drones, edge computing, etc., etc. I can keep telling, and each and see that itself. If I listed it, take another 1 hour. So without wasting much time, thank you very much. Even I had another 5G technology sessions there. I'm now thinking of booking you as a resource person for that. It's a small group, like compared to AI. A lot of people have registered, but due to exams, I think they have not turned up today. Again, thank you very much, whoever came for participating here and enjoyed your session, I hope. Thank you for participants. Thank you very much, Sohan, once again. And we'll meet you again in some other occasion. Thank you, Wandandal. We can wind up now. Thank you very much. Thank you. Nice talking to you. Nice to have you. And
Thank you,
we'll meet
Suleiman.
in another occasion. Thank you. Thank you.
All the best, everyone. Thank you.
Thank you. Thank you, guys.